Today we will be solving systems by graphing first, and because graphing, if we do it with paper and pencil, there's human error. We are actually going to be using our graphing calculators to solve all systems by graphing. The second method you'll be seeing today is using substitution. So first of all, we need to talk about what a system of linear equations is. This is the whole chapter will be about systems of linear equations. So linear systems are two or more linear equations together. So they're taking two linear equations and they're putting them together, and sometimes there's more. This chapter, generally speaking, we will only see two at a time. A solution to a system of linear equations is the following. Any ordered pair that makes all equations true. So it has to work in both of them. When we are graphing, and let me drag this up real quick so we can see it. When we are graphing, it is the point of intersection. Okay, so our first one here, like I said, we are going to be graphing, and we're going to be using graphing calculators. So we need to remember how to put that in. Since y is by itself on both of them, they're ready to be entered into the calculator. So you hit your y equals button, and I'm going to enter in the first equation of 2x minus 3. I arrow key down, and I enter x minus 1. I can then hit the graph button. And if you did not reset your window before you started, I would make sure you do that. So reset your memory. So that is at negative 10, 10, negative 10, 10. So once you have that, it is on the thing. There are two lines because we had two equations. I need to find the point of intersection. To do that, you need to hit second trace, and the point of intersection is 5. Enter the first curve, enter the second curve. Yes, we want them to guess the answer. So our point of intersection then is going to be the point 2, 1. The good thing about this chapter is we can check all of our answers to see if we are correct. So if I check it in this first one, we know y is 1 and we know x is 2. 2 times 2 is 4. 4 minus 3 is 1. So it works in the first one. On the second one, if I plug in 2 for x and 1 for y, 2 minus 1 is 1. So it also checks out in that. So since it checks out in both equations, that means we do have the correct solution of the ordered pair 2, 1. On our next one, again, we're solving by graphing, and it asks you, before graphing, what do you notice? Well, if I'm glancing at these, I notice that the slope is negative 2 for both of them. So same slope. Okay, I'm going to go ahead and I'm going to graph it. So I'm going to my y equals window again, negative 2x plus 1. And negative 2x minus 1. And if I graph it, and then I'm going to do second trace 5 for point of intersection, and it gives me an error. Okay, well, the reason it gives me an error, if you remember, if I noticed I had the same slope and different y-intercept, well, we should know that if we have the same slope and different y-intercepts from last chapter, that these are parallel lines. Well, if they're parallel lines, they never cross. Well, they don't cross, we don't have a point of intersection, which means there's going to be no solution. So my answer here is no solution. There's not a single point where those lines cross. So there's not an x and a y that you can sub into both of them and have it work for both. Our next one says, again, we need to have y by itself each time. So I need to rewrite this first equation and get y by itself. So I'm going to subtract 2x on both sides. And I end up with 4y equals negative 2x plus 8. I'm going to divide by 4. And I get y equals negative 1/2 x plus 2. Again, it's asking us, what do you notice? I notice their slopes are the same, And this time, the B is also the same. So M and B are the same in each. Well, if they're the same in each, that means it is the same line. Let's go ahead and enter it into our calculator so we can see what it's going to look like in our calculator. We're going to go to our y equals window again. You have to plug in where you have the y by itself. So I'm going to plug in for the first equation, parentheses, -1 divided by 2, close my parentheses, x plus 2. And my second one is going to be the exact same. Parentheses, -1 divided by 2, close my parentheses, x plus 2. And I graph. This time, even though I entered two equations, I'm only seeing one line. And we talked about it, it's because it is the same line. So if I don't pay attention to what I'm doing, and I go ahead and I hit second trace intersect, it actually does give me an intersection point. But the problem is it only gives us one. If they are the exact same line, every single point on the line is going to work. So if it is the same line, it is said that this system has infinitely many solutions. Because you could pick any point on this line and it would work. So parallel lines have no solution. If it is the same line, it's going to have infinitely many solutions. Okay, our real world connection on this one says, suppose you are testing two fertilizers on bamboo plants A and B, which are growing under identical conditions. Plant A is 6 centimeters tall and growing at a rate of 4 centimeters per day. Plant B is 10 centimeters tall and is growing at a rate of 2 centimeters per day. Write a system of equations, so that means I'm going to have at least two equations, modeling the height of the plant, h of d, as a function of days, d. So I'm going to do h of d, and this is going to be for plant A. This would be the b, because that's the initial height. The rate is always our slope, which is m. So we have 4x plus 6. Now I will do the same for b. Again, it's the height as a function of d, and the rate is 2 centimeters per day. Oops, I should put a d here. Sorry about that. This should also be a d because it says h of d. So it's 2 centimeters per day, so that's why it's times d, plus the initial value, which was 10 here. All it asked me to do was to write the system. It didn't actually ask me to solve it. So my answer is right there. Okay, now on example 3, it's saying, using your system written, which models the heights of the bamboo plants in example 2, so from right here, our system we just wrote, find the solution of the system by graphing. What does the solution mean in terms of the original situation? So again, we're going to our graphing calculator, and we're going to enter in our two equations. For equation 1, I'm going to put 4x, because you can't put in d, it has to be x or y in our graphing calculator, plus 6. And for our second equation, we're putting in 2x plus 10. We're going to graph it. They do not have the same slope, so they're not parallel. And they're also not the same line. And then we're going to hit second trace for intersect. And it says my point of intersection is at the point 2, 14. If I check to make sure I'm right, 4 times 2 is 8 plus 6 is 14, so it worked in the first one. If I check it in the second one, 2 times 2 is 4. 4 plus 10 is also 14. So it does work in both of them, so our point of intersection is correct. Okay, it does ask, what does the solution mean in terms of the original situation? This means on day 2, they will both be (14 centimeters tall. That's the only day that they'll be the exact same height. Okay, let's go ahead and let's turn our page, and we are actually going to be starting the substitution method now. So we're done with graphing, so we're done with the graphing calculator. We are going to be using the substitution method. So the substitution method is our second method that we are going to learn to use to solve systems of equations. So the substitution method, again, is another method for solving a system by replacing one variable with an equivalent expression containing the other variable. Get it to let me move it. There we go. Okay, so here's our first example. We want to use substitution to solve this. Obviously, we could use graphing again, okay, but we are going to be asked to use different methods, and then at the end, you'll be able to use the one that you like the best. So it says you're going to replace one variable with the other part. So if I look here, this one says y equals negative 4x plus 8. So I know y is equal to this. So I'm going to take this and I'm going to substitute it, that's why it's called substitution method, in for the y in the other equation. So I'm going to rewrite it as negative 4x plus 8 is equal to x plus 7. The reason we do that is because it eliminates one variable, and now I only have one equation, one variable, so I can solve for x. So I'm going to subtract 1x from both sides. That gives me negative 5x plus 8 equals 7. I'm going to subtract 8 from both sides. I get negative 5x equals negative 1. I'm going to divide by negative 5, and I end up with x equals 1/5. Remember, we are looking for the ordered pair that will work in both of them. So once I have it, then I need to sub it into one of the originals. It doesn't matter which one. I'm going to choose this one just because it's simpler. It has less numbers in it. And I'm going to sub it in, and I'm going to solve for y. So I know x can be subbed in as 1/5. So I rewrite it as y equals 1/5 plus 7. Y equals 7 and 1/5. I now have my x and y, so my last step is to write it as the ordered pair of 1/5, 7, and 1/5. And remember, you can go ahead and you can always check your solution by subbing it into both of them. So we actually sub in twice. We sub it in to the original, and then we're going to sub our answer in once we have it to solve for the other variable. Okay, our next one here is y equals negative 2x plus 1 equals y equals negative 2x minus 1. And it asks, what do you notice? I notice right away that the slopes are the same. And the b is different. So since I notice that, I automatically know that these are parallel lines. Okay, let's look and see what this will look like when we actually use substitution method. So y is equal to this. I'm going to circle it, and I'm going to sub it into y for the second equation. So I'm going to rewrite it as negative 2x plus 1 equals negative 2x minus 1. I'm going to add 2x to both sides, and I'm left with 1 equals negative 1. Well, I know that 1 does not equal negative 1. Well, that is because there is no solution, which if you think back to when we were graphing on the front side of this page, or if you flip over, we said parallel lines don't have a solution because they don't intersect. Well, if you go ahead and you solve it using the substitution method, you come up with the same answer. 1 does not equal negative 1, therefore my answer is no solution. So if you automatically realize that they're parallel lines, no matter what method you're supposed to use, you can always write no solution as your answer and not even have to work it out. We have one more type here. if we look here and it says substitution, y is by itself here. So I'm not going to notice anything before I graph because they're not in the same format, so I'm not going to notice anything. I do notice that this y is by itself, so I can take this part here and I can sub it in for y in my first equation. So when I rewrite it, it looks like this: 2x plus 4 times y. Well, I'm going to substitute this all in for y. And then it still equals 8. And now I need to solve this equation for x. So I need to use my distributive property. 2x plus 4 times negative 1/2 x is negative 2x. 4 times 2 is 8. Okay. And I have 2x minus 2x. 2x minus 2x is 0. That cancels out. And I'm left with 8 equals 8. 8 does equal 8. So if 8 does equal 8, that means that I'm going to have infinitely many solutions. And remember, we did this one on the front page as well. And it came up with the same answer. And the reason it has infinitely many solutions is because it's actually the exact same line. So all points of intersection would work in both of them. Okay, our last one here. On substitution, you have to have a variable by itself. Neither one of these equations have a variable by itself. So what I'm going to do is I'm going to pick this y to get by itself. And the reason I chose this y is because it doesn't have a coefficient. So to get this y by itself, I'm going to add 6x to both sides. And now my new equation is y equals 6x minus 7. I now have a variable by itself, so now I can use substitution. I'm going to take this part and I'm going to sub it into y in the other equation. When I sub it in for y, it's going to look like this. I have the coefficient of 3. Y I now know is equal to 6x minus 7 plus, and everything else stays the same, 2x equals 4. One equation, one variable, I need to solve it for that variable. I use my distributive property, 18x minus 21 plus 2x equals 4. 18x plus 2x are like terms, so I can put them together as 20x minus 21 equals 4. The opposite of minus 21 is to add 21. I'm left with 20x equals 25. The opposite of times 20 is to divide by 20. And I end up with x is equal to 1.25. So I now have my x number, and I'm going to sub it in and get my y. I would always sub it into the one that had the variable by itself. Here the variable is by itself. Y equals 6x minus 7. So I'm going to take this x and I'm going to sub it in right there. So y is equal to 6 times x, which is 1.25, minus 7. I can put that all in my calculator at once, and it gives me y is equal to 0.5. I now have my x and y, so my last step is to write it as the ordered pair of 1.25, 0.5. Remember, you can go ahead and sub these in to the original using a calculator and see if it works. So if I'm going to sub it in to this one first, I would do 3 times x, and we know, or 3 times y, and we know y is 0.5, plus 2 times x, and x is 1.25. When I put that in my calculator, it does give me 4. So it checks out in the first equation. To check it out in the second equation, I would do the following. Negative 6 times 1.25 plus y, which is 0.5. When I do that, my calculator gives me negative 7, so it checks out in the second equation. That means this has a 1 point of intersection, so So that means it only has one solution of 1.25, 0.5. Our last example here is the real world problem solving. It says your school is planning to bring 193 people to competition at another school. There are 8 drivers available and 2 types of vehicles. You can take a school bus and they can take minivans. The school buses seat 51 people each and the minivans seat 8 people each. How many buses and minivans will be needed? Well, since we only have 8 drivers, I know I can only take buses plus the minivans can only equal 8 because I only have 8 drivers. I then know that the school buses seat 51 people. 51 people can fit on the bus plus 8 can fit in the van for a total of 193 people. Okay, it didn't just tell me to write the system of equations this time. It says how many buses and minivan will be needed. So now I need to go ahead and solve it. It did not tell me what method to use. I don't particularly like graphing, so I'm never going to use graphing unless it tells me I have to. So I'm going to solve this first equation for one of the variables because I can't use substitution unless I have a variable by itself. So I'm going to take this equation and I'm going to rewrite it and get b by itself. To get b by itself, I need to subtract v. So I do 8 minus v. So now b's by itself, I can take this and substitute it in for b and rewrite my second equation. 51 times b, but I'm going to put b, and that's a 51. Didn't show up very good. 8 minus v plus 8v equals 193. I'm going to use my distributive property here, and I have 51 times 8, which gives me 408, minus 51v plus 8v equals 193. And I need to solve this for v. So I need to put negative 51v and 8v together because those are like terms. And that gives me negative 43v. If I can get it to work. Is equal to, and to move a positive 408, I'm going to subtract 408. And I end up with negative 215. I need to divide by negative 43. And I end up with v equals 5. That means I can take 5 vans. I now need to see how many buses I can take, so I'm going to substitute this in up here for v. Buses is equal to the 8 minus 5 vans, so I can take 3 buses. So I need to write this in statement form. The school will need 3 buses and 5 vans. And let me get that where you can read it all. There we go. And we are done. You can go ahead and complete your quick checks and then look at your schedule for your assignment.